Today we will learn about binary tree traversal, okay? Binary tree traversal. So three types of traversals are there. Traversal means you have to traverse your given binary tree and you have to write the nodes that are visited in a sequential manner. Okay, you have to write down the nodes that are visited in certain rules: in order, pre-order, and post-order. There are three traversals are important in tree: pre-order, pre-order, next in order, and next post order. So this is your post order, sorry, post order traversal, in order traversal, and pre order traversal. Three traversals are there. Suppose this is the main rule, please follow it carefully. If this is the root, this is the binary tree, okay, and we assume that there will be two children. For our example, there will be two children in this example, okay. So this is your root, this is your root node of your tree, root, and this is the left child of your root, and this is the right child of your root. Now you have to traverse the binary tree using either in order or pre-order or post-order. So pre-order means, pre-order traversal means this sequence: root, left, right. This is the pre-order traversal, okay. In order traversal means left, root, right. And post order traversal means left, right, and then root. Okay. So pre-order. So pre-order means root, next, left, next, right. Root, left, right. In order means, what is in order? In order means first left node is visited, then root is visited, and then right is visited, okay. But post order means first left is visited, then right is visited, and then root is visited, okay. So these are the sequences, okay. Root, left, right, then left, root, right, and then left, right, root. In your exam, like mac-out exam or any competitive exam or gate, net, set, you will be given, there will be two types of problems, okay. So first of all, implement the uh, three traversal um, algorithms and its code. So this is one type of problem. Its code means C code. This is useful in your lab exam. So implement that tree traversal algorithm. This is for mac-out. This is important for mac-out exam. Another type is draw draw the tree. Draw the tree if if in order is given and either pre order or post order is given. So we can draw the tree, if and only if, I double if and only if always the in order is given. Okay, always the in order is given and either the pre-order or post-order is given. Suppose pre-order traversal is given and in-order traversal is given, you are asked in your exam to write down the post-order traversal. That is, first of all, you have to draw the tree and then you have to find out the post-order traversal. Okay, or post-order traversal is given and in-order traversal is given, you are asked to find out the pre-order traversals. That is, you have to draw the tree and then find out the pre-order traversal. Okay, so this is another type of problem. Actually, this is one of the most important type. Draw the tree, and again draw the tree. Again draw the tree if it is given that draw the tree if it is given that tree is EST and either pre-order or post-order is given. Tree is binary search tree. Okay, so we have to draw the tree given that your tree is binary search tree. What is binary search tree? Binary search tree is a binary tree. Okay, with the properties that this is a binary search tree. Suppose this is your root BST. This is your root and this is the left and this is the right. So for binary search tree, if it is a BST, then it should be first binary tree. For binary search tree, the left sibling, the left child must be less than is equal to root and root must be greater than right sibling. So this is the property for binary search tree. So if it is given that your tree is binary search tree, then it is enough that either by using pre or post order you can draw the tree. In order traversal is not needed in that case. Binary search tree, this condition is enough. Okay. So let one example. Is it clear up to this?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Just one
Yes, sir.
second. Binary.
Yes, sir.
I'm searching for a gate question. It is given that binary search tree. Okay. 2018. So 2018, it is given that sorry, the post order traversal, the post order traversal of a binary tree. Okay, post order traversal of a binary tree. Post order traversal of a binary tree. Post order traversal of a binary tree. It is given that 8, post order traversal 8, 9, 8, 9, 6, 7, 8, 9, 6, 7, 4, 5, 2, 3, 2, 3, 1. Okay. 8, 9, 6, 7, 4, 5, 2, 3, 1. Okay. The post order traversal of binary tree. It is given that it is a binary tree. So in order traversal should be given. It is mandatory. Otherwise, we can't construct the tree in case of binary tree. In order. In order traversal. So in order traversal. So in order traversal of the binary tree is that, in order traversal is that 8, 9, 8, uh, 6, 9, 8, 6, 9, 6, 9, 4, 7, 2, 5, 1, 3. Okay. How many nodes are there? 2, 3, 4, 5, 6, 7, 8, 9. Okay. So my question is that find out find out the pre-order pre-order traversal. Find out the pre-order traversal. Okay. So first of all, the post order traversal. Post order means what is post order? Anyone? Post order
Post order
traversal
is left, right, root.
left, right, root. And in order means left, root, right. Okay, left, root, right. So in post order, the root is, what is the root? Here, what is the root? This is the post order traversal.
Six. Six
This,
is the
this is
root.
the post order traversal. And according to post order traversal, root is at the last node. So here from the given sequence, which one is your root? Any idea?
Six is one root, I think.
6 is root.
For the top first one, will want six be a root.
According to post order traversal, first left comes, then right comes,
One.
then root comes. Okay, root
So
is
one
at
one is the root.
last. Yes, one. Very good.
So
So
then
the
all
sequence
the
is
left.
given. The sequence is given. The sequence is given, and at the right side, one is there. Okay. So if you scan the post order, you will get the root at the last entry. If you scan the pre-order, you will get the root at the left side. Is it clear? If you scan the whole
Yes, sir.
tree in
Yes,
a
sir.
in a pre-order traversal, if you scan the whole tree in a pre-order traversal, as pre-order means root comes first, so at the left side denotes the root. So here one is the root. So 1 is the root. So we have to draw 1. So 1 is the root. Okay. Now, as 1 is the root, now in order means root belongs to the middle one. Is it clear? According to in order, the root must lies in the middle one. At the left part, left child belongs. At the right part, right child belongs. Root is kept at the middle side in case of in order. So from this given sequence, it is clear that root is at the right one according to post order traversal. Now just scan the in order traversal. So 1, here 1 is found, and 8694725, these are the left siblings, left child, sorry, left child, and 3 is the right child. So left and right. Right is your 3 and left is the 869. Left is the 8, then 6, then 9. 869, 869, 4 7 4 7 4 7, next 4 7 2 5 2 5. Is it clear the concept?
Yes, sir.
Yes, sir.
So
Yes,
these
sir.
are the, so these are
Yes, sir.
the left child, and this is the right child according to the in order traversal. Okay. Now one is complete. Okay. So one is complete. Now the right portion is 3. Okay. Now at the right portion we get 3. So this is the root, 3 is the root. According to the post order traversal, 3 is the root because these 3 is at the rightmost entry of your sequence, present sequence. So 3 is the root. Okay. Now this is the given tree. So 3 is the root. So 1 is one root and 3 is another root. It is complete. Now 3 complete. Next rightmost entry is your 2. Now you have to scan the 2 here. Now just find out. Here this is 2. Okay. So at the right part of your 2 is 5 and at the left part of 2 is 86947. So this is your left root 2 and 5 is the right because why 5 belongs to the right part. This is 2 and 5 resides at the right part of the in order traversal. So that's why this is 5 and here 8 6 9 4 7. Okay. Is it clear?
Yes,
Yes,
sir.
sir.
Please ask me if you have any question, any query. Now 2 is complete. Next entry 5. So 5 is the root. Now identify where is 5. Here this is the 5. So 5 is the root because it has no children. 5 is the root. Okay. Next, so 5 complete. Next 4. You have to find out 4. Here this is 4. So 7 is at right portion of 4 and 869 is at the left portion of 4. So 4 is the root. 4 is the root and this is the 7. 7 is at the right side and 869. 8, then 6, then 9. 869. 869. Okay. Now 4 complete. 4 is the root. Next 7. Now 7 is the only one child of the right part, and it has no further leaves. So 7 is the root. Next, find out 7 complete. Next, find out 6. So 6 at the left side of 6 is 8 and the right side of the 6 is 9. So 6, so left part of the 6 is 8 and the right part of the 6 is 9 and 6 is the root. Okay. So 6 complete. 6 complete. Next 9. 9 is the root. So 9 is the only one part and it has no further leaves. So 9 is the root. And then 8 is the root. Okay. So 8 is the root. So this is the tree. So the final tree is 1, 2, 3. 1, 2, 3. Okay. So from 2 we can get 4 and 5. 4 and 5. This is a binary tree. Next, from 4 we can get 6 and 7. 6 and 7. From 6 we can get 8 and 9. So this is the tree. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
So what is the depth? Can you find out what is the depth of the tree? Can you find out the depth of the tree? Depth or height is same.
5.
5.
5.
4.
Four.
Height or yes, height or depth means
4, 4.
you have to simple one. You have to count the number of branches starting from the root and to the farthest leaf. So number of branches starting from the root to the farthest leaf. So 1, 2, 3 and 4. So height is 4. Okay. So this is the tree, binary tree. Now you have to find out the pre-order traversal. How can I find out the pre-order traversal? Can you find out the pre-order traversal? Anyone? Okay. Pre-order, I'm showing this. Pre-order means first root. So this is the pre. This is the pre-order. Red one is the pre-order. Okay. And this is the yellow one is the in order traversal. And the blue one is the post order traversal. Okay. Post order traversal. Now we have to find out the pre-order traversal. So pre-order traversal means first you are at the root. Okay, so write down 1. Then you have to go to the left branch. So left branch means this is the left branch. So first complete this left branch, then complete this right branch. Okay. So this is the rule. First you have to encounter the root, then the left branch, then the right branch. Actually, this is the recursive calling. Okay. So you can implement the tree traversal using recursion. Okay. So root is complete. Then you have to scan for the left part. So inside the left part, you will get first 2. Okay. So you have to write down 2, right? Then you have to scan for the left part and then the right part. Okay. So at the left part, after entering in the left part, you will get 4. So write down 4. Then you have to scan the left part. So after getting the left part, you will get 6, then 8. Then what should I write? Anyone?
So 9753.
Yes, 9. Why 9? Because after scanning the 6, you have to go for the left one, that is 8. Okay, so complete. From 8, 8 is the leaf node, and from 8 you will get no other branches. So 8 is written. Now you have to look for the right one, that is 9. So 9. 9 is complete. 9 is complete means total this subtree 6, 8, 9 is complete, fully complete. Okay. Now, now this 4, 6, 8, 9, 7 from this subtree, the root is complete, the left child is complete. Now we have to write the right child. So 7, 9, 7. Similarly, after that 5, and then 5, then 3. So 1, 2, 4, 6, 8, 9, 7, 5, 3. This is the in order traversal. Is it clear? Is it clear to you?
Yes, sir.
Yes,
So
sir.
Sir,
height,
in order to pre-order.
Yes, sir.
pre-order, pre-order. This is the pre-order.
Okay, sir.
আমি কি in বললাম?
হ্যাঁ
Oh, sorry. This is the pre-order traversal. So height is 4 and you have to find out the pre-order. So this is your pre-order. Okay? Pre-order. বোঝা গেছে তো?
yes sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So next question. Next question. The post order traversal is given in this form. B, 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 F, E, A, G, C, L, J, H, K. Okay. And this is the post order. B, B, F, E, A, G, C, hmm, K, G, H, K, L. Okay. Now post order means post order F, E, B, E, B, G, L, G, L, J, K, J, K, H, C, A. So the post order and in order traversals are given. What will be the pre-order traversal? Can you do that? Anyone?
Yes, sir, we can do that.
So find out the pre-order traversal. Is there any confusion?
Sir, can you show the question? Yes.
If you have any query, please without any hesitation clarify your queries. should I explain this particular problem?
So maybe we can try, and if
Okay,
we have a problem.
just find out the pre-order traversal. Please, everyone, do that. So pre-order means I'm just writing pre-order means first process the root R. Process the root R. Okay. Next, traverse traverse the left sub subtree of R in pre-order. Okay. Next, traverse the pre-order. Actually, this is the recursive definition. Traverse the right subtree of R in pre-order. Okay. So this is the rule. In order means traverse the left subtree of R in order. Okay. Next, process the root R, and then traverse the right subtree, Okay. Now, here traverse the left subtree of R in post order. Traverse the left subtree of R in post order, then traverse the right subtree, right subtree of R in post order, then process for root. So this is the general rule for pre-order traversal. This is the pre-order traversal. Next, in-order traversal. Next, post-order traversal. Okay. So, what will be the pre-order traversal of given
Sir,
problem?
I solved and got answer. I wrote it in the chat box. Like, if you can check.
A B D E. Yes, it is correct. Yes, this is correct.
Okay, sir.
আর তো কেউ শো করাচ্ছে না। Is it clear to you? Okay, so first of all, আচ্ছা এটা হোমওয়ার্কই থাক, ঠিক আছে নাকি? পারবে তো? দেখিয়ে দিচ্ছি এরকম। Find out the post order traversal. Find out the post order traversal, the pre order traversal. So A is the root. The post order sequence is given in this form. So at the rightmost one, A is the root. As A is the root, now we have to find out the A in the in order traversal. So A is the root. So write down A is the root. Okay. So left part and right part. You have to find out the left part and the right part from the in order traversal. So at the left part, D, B, F, E. D, B, F, E. D, B, F, E. D, B, F, E. At the right part, G, C, L, G, C, L, J, H, K, H, K. Okay. Next, from the post order, C is the root. So from the post order, C is the root. So C is the root. Okay. So C is the root. So C at the left side, this is G, and at the right side, L, J, H, K. So L, J, H, K. And at the left part, G will be there. Okay. So C and A complete. Next, H. H is the root. So H is the root. So obviously H is the root. So right part is K and left part LJ. Left part is LJ. So left part is LJ. Left part is LJ and right part is K. Okay. So H complete. Next K. So K is the only one node. So K is complete. Okay. Next J. So J at the left part of J, L is there. So J is the root, and at the left part of J, L will be there, and L is the root. So J, L complete, J and L complete. Then G, G, then G is complete. Then G is complete. Okay. Now B, B is the root. So left part of B is D and right part of B is F and E. So B. So B is the root. And this is the D and this is the F and E. F and E. Okay. F and E. So B complete. Next E. So E at the left part of E, F is there. At the left part of E, F is there from the in order traversal. So write down F, as this is the leaf nodes. So F and T are the leaf nodes. Okay. So this is the tree. A. So the tree is A, B, A, B, D, E, F, C, G, H, J, K, and L. So now if we apply the pre-order traversal, so according to the pre-order traversal means we have to scan the route first. We have to scan the route first. So first A is scanned. First A is scanned. Okay. Then cover the left subtree of A, then right. So inside the left subtree, B is scanned. Shorashish, please check. Then B is scanned. Okay.
Yes, sir.
After B, completion of B, you have to check the left subtree. So D is there. Okay. D is there. Then you have to go for the right child. So inside the right child, E will be the root. So that's why scan the E. Then left child of E. So F will be there and there will be no right child. So complete. So total entire left portion is complete. Left portion of A is complete. Okay. Then you have to go for the right part. So inside the right part, you will get the root C. Then you have to scan for the left part of C. Left part of C, the root is G. It has no children. So go for the right part. So inside the right part, H is the root. So H is the root. Then go for the left part. So this is the left part. Inside the left part, root is J, and then go for the left part of J. So you will get L. Okay. No right part. So cover the whole left part. Then you have to go for the right part. So K. K is the right part. Is it clear?
Yes,
This
sir.
is
Yes.
Yes, sir.
this is the pre-order traversal. Okay. Now you have to find out the binary search tree is given. Binary search tree is given, and you have to find out the mm, yeah, pre-order is given, and binary search tree is given post order. Okay. So these two problems quite good. Then 2013. There are several questions. Uh, pre-order. Pre-order. Pre-order traversal of BST is pre-order traversal of BST is 30, 20, 30, 20, 10, 15, 10, 15, 25, 10, 15, 25, 23, 23, 39, 39, 35, 42. Okay. So find out the post order. Find out the post order. Find out the post order traversal. Find out the post order traversal. It is given. The pre-order traversal is given of a binary search tree. So this is from 2013. Uh, Traversal. Just 1 second. Binary search tree. Binary search tree contains number of nodes. When the tree is traversed, uh, when the tree is traversed pre-order, the values printed. Okay. So another question, 2005. P-order traversal, find out the post-order traversal. Pre-order traversal is given that pre-order traversal is given that 5, 3, 1, 2, 4, 6, 8, 7. Okay. And uh, 2005, the post-order traversal, find out the pre-order traversal. Post-order traversal of a binary search tree. Binary search tree is given that 10, 9, 23, 22, 23, 22, 27, 25, 15, 50, 95, 60, 40, and 29. To find out the post-order traversal. So there are 3 problems. There are several problems over this kind of problems, okay? This kind of traversals. So first of all, the post-order traversal of binary search tree is given in this form. Pre-order. Pre-order means first root, then left, then right. Okay. So what is the root here? What is the root?
30.
So 30 is the root. So 30 is the root. We have to draw the 30. 30 is the root. Okay. Now it is given that it is a binary search tree. Just after finding out the root, you have to apply the binary search tree property. What is the property of binary search tree?
Left is less than equal to right is greater than.
So left is less than equals to and right is greater than. Okay. So first of all, arrange all the entries in this fashion. So 20, 10, 15. So 20, next 10, 20, 10, 15, 20, 10, 15, 20, 10, 15, 25, 23, 25, 23. Okay. 39, 35, 42. 39, 35, 39, 35, 42. Is it clear? The branching, is it clear? The branching is clear?
Yes, sir.
Yes.
So as this is the binary search tree, every nodes in the left portion are less than equals to 30 and nodes belongs to the right subtree are greater than 30 root. So this is the properties maintained. Next, so 30 is complete. 30 is complete. So next root is, this is the pre-order. Pre-order means first root, then left, then right. So 20 is the root. So 20 is the root. Okay. Now again branch the 20. So less than equals to means 10, 15, 10, 15, and greater than means 25 and 23, 25 and 23, 25 and 23. So all are less than equals to 20 and all are greater than 20. Okay. Next 20 is complete. Next 10. So 10 is the root as we are scanning that binary search tree in a pre-order fashion. So next one is 10. So 10. So what will be the position of 15? Anyone? Position of 15?
Right
Right.
there.
Right.
Right.
So 15 is placed at the right. So greater than. So 10 complete. Next 15 is also complete. Now 25. Now 25 is there. So 23 is less than equals to 25. So 23 will be placed in this form. So this is less than equals to. So 25, 23 complete. Next 39. So 39. So 39, 35 is less than equals to 35 is less than equals to 39 and 42 and 42 is greater than and 42 is greater than 39. So 39, 35, 42 complete. Now we have to find out the post order traversal. Now observe carefully, 30 is the root. Now all elements at the left part are less than equals to 30 and all elements in the right part are greater than 30. This 35 which is less than equals to 39, this is also greater than 30. This 42 which is greater than its immediate root 39, it is also greater than 30. This 23 which is less than equals to its root, its predecessor 25 which is also less than equals to your 30. So at every step you have to maintain the binary search tree property. So if the binary search tree is given and either pre-order or post-order is given, then you can easily construct the in-order traversal is not required. Okay. So uniquely pre-order or post-order traversal is enough if it is given that it is a binary search tree. Otherwise, you have to supply the in order in association with the pre-order or post-order. Okay. So what is the post-order traversal? Anyone? What is the post-order traversal? The tree is constructed here.
Sir, I wrote, uh, I tried one attempt.
Chat.
Yes, sir.
Yes. So we have to construct the post-order traversal. So post-order traversal means post-order. Post-order means first is left, then right, then root. Okay. So first is left. So 30, this is not the left. Go in the left branch. First of all, 30. Next, 20, 30, 20, 30, 20, 39. 30, 20, 39. Next 20, from 20 will get 10. 10 and 25, 10 and 25, 10, 25, and from this 10 at the right part you will get 15, from 25 at the left part you will get 23. Okay. 39, 39 at the left part of 39 you will get 35, 35, and at that portion you will get 42. So this is the tree. Now 30, post order traversal. First is left. So left, no left is there. Left is blank. So you have to scan the left, then is right. So right is 15. Left, right route. So left is complete, right is complete. Now you have to write down the route. So 15, 10. So this one, just 1 second. This this one complete. Next 23. Next 23. After that, no right subtree is there. So write down the root 25. Okay. 25 complete. Next complete the 20. So this portion complete. Right portion. Inside the right portion, 39 is the root. Discard these roots. You have to write down the left. That is 35. Then you have to scan the root. Sorry, right. 42. Then 39. Shorashish, is it clear?
Yes, sir.
Now calculate the this one. Very simple. 2005. Is it visible? 2005.
Yes.
Yes.
So
Yes,
what is
sir.
the post order traversal? Yes, this is the answer. 21437865. Okay. So traversal of binary search tree and binary tree. Is it clear to you?
Yes, sir.
Yes, sir.
Okay. Can you find out the output? Is it visible?
Yes.
Yes, sir.
Yes, sir.
So what will be the output and why? You have to explain. Anyone? What will be the output?
Sir, trying.
So 4321.
4, 3, no.
It can be 1234.
Mhm.
So
1234.
just 4.
No, not 4.
Sir, there will not be any output.
Why? Printf is
Can
there.
you please show the screen once more? Yeah, please show screen once more.
Oh, just 1 second. Just omit these 2 lines. What will be the output? Showmo. If x is
One.
0, huh?
Sir, one output of one.
No, zero.
Zero greater than zero. हाँ zero होगा.
3, 4.
Single question, multiple answer. Suraj, according to you, কিছু একটা ping করলো মনে হয়. No. 5. Sneha, are you there? Sneha 9052.
Yes, sir.
What will be the output?
Sir, I also think zero.
0. Okay, just run this code. My fun, and if x is 0, then minus minus, then x, and print that x, and value of x is 5. Build and run. 0, 0, 1, 2, 3, 4. This is the output. Can you explain? Suppose this is 10 instead of 5. Then build and run. So starting from 0, it will be ended at 9 and 1 extra 0. You can eliminate this extra 0 by just inserting one simple bracket. Here this is the bracket, and that is printf line is taken inside the if block. So build and run. So here the extra 0 is gone. Now can you explain the code? Anyone? Actually, one hint. It is the application of stack. This is the application of stack.
Um, I think I can explain.
Okay, carry on.
Uh, Sir, when the value is 5,
So when the value is 5, okay. So the value is 5, then
yeah, so when we first run the function, it is obviously x is obviously greater than 0.
so
So
5 is greater than, 0 at the iteration 1. At the iteration 1, 5 is greater than 0. Then
so this function will be again called with minus minus x, which means the value of x will be decreased to 4.
so 4 is written here.
Yeah.
Next, it is
Then
pushed.
again, yeah.
Then
Then again the same thing will happen, that 4 is greater than 0. So
so 3 is
again the function will
inserted here. Next,
similarly 2, 1, etc.
similarly to 1.
Then
1 means 1 means 1
value,
means when 1 is greater than 0. When 1 is greater than 0, then my function will be 0
yeah,
minus minus 1, that is 0.
yeah,
So 0 is inserted.
yeah,
So 0 is inserted. Okay.
yeah. And
Next, 0
next
is
time,
greater than 0 is greater than 0. No,
no,
false. So line number 7 will not be executed. Now one extra printf is there. Line number 8. So what is the value of x? At present
0.
value of x is 0. That's why 0 is there. So now you have to pop, because this is the last in first out structure. Stack is actually, this is the application of system stack. In your C compiler there will be a system stack. So this is the application of system stack. So first push and then pop and write down the output. So output is first 0 is outed, next 0, so 0 0 1 2 3 4. And if you apply the bracket here, then Saurashish, if you apply the bracket here, then
So if we apply the bracket, then obviously the first 0 won't be printed as the
yes,
printf is inside the if.
yes, as the printf is inside the if block, it will not be executed the last 0, last inserted 0. Okay, is it clear? Anyone? Suraj?
Yes, sir.
Suraj, is it clear to you?
Yes, sir, it's clear.
Okay. Suppose sorry, int star a and stack top. Okay, now we are writing the function int stack function int op and int v. Okay, now we use the static int size is equal to 0 and stack top is initialized with 0. Okay, and switch your opcode op and write down three cases. Case one, sorry, case one, case minus one, case minus one. Case minus one means here. Sorry, size is equal to, here size is equal to your v. Size is equal to v and then break. Okay, case 0. Case 0, inside the case 0, if your stack top, if your stack top is less than equals to, your size, is less than is equal to your size, then a stk stack top plus plus is equal to v and then break. And then break. Okay, sorry, default. So default if stack top, if stk top means stack, if stack top means, any idea?
Sir, if the value of stacked up is 0, then it won't be executed. If it
That
is
is, if
1,
stack top is true,
yeah.
if block will be executed for uh, non-zero value.
Everything except 0, yeah.
Suppose if -5 printf high, if 5 printf if 0, so what will be the output? Suraj, is it visible? Is it visible to you?
Yes, it is visible.
So what will be the output? Anyone?
Sir, hi, hello will be printed. Good won't be printed.
Yes, because if block will be executed for a non-zero value. Okay, so if non-zero value -5, this is a non-zero value. Okay, actually, if x is equal to, the main funda is that if x is equal to -5, if x is equal to -5, then suppose it is given x is equal to -5, then printf high, 84 Is it a valid statement? X is equal to -5?
Sir, we need we don't have any variable named x here.
Just okay. So int x and initialize x is equal to okay, int x, just int x. Is it a valid?
No, sir. Like it
Why
will be
not? Why
garbage
not?
value.
So
It,
x will contain so x will contain a garbage value,
yeah.
okay? And the garbage value is this is the comparison operator, and this garbage value is compared with the -5.
Yeah.
So either this is true or false, either it is executed or not.
It won't be executed because garbage values are some like different values which never.
So if x is equal to -5,
Then it will be printed. Only hi will be. No, hi and hello both will be printed.
both will be printed because -5 is compared with -5. So this is true. So true means non-zero. True means 1. Okay. So if x is equal to -5 and you place x double equals to -5 inside the if block, actually it means 1, non-zero value, non-zero value. So you can write 87 here, non-zero value. So it will be printed. But if this is a zero value, it will not be executed. So if block will be executed only if it has a non-zero value. Just run the code and test. Hi and hello will be printed. So good will not be printed because this will contain a zero value. So if stack top, so this is true. If this is true, then return minus minus uh, stk top, return this. Okay, and finally return -1. Okay, and inside the main inside the main we are writing int b array with 20, a is equal to b, and backtop is equal to -1, initialized with -1. Now stk function, and stk function is called stk function. So -1 and then so opcode is op is -1 and 10 is the variable val. Next stk function, let this is 05 05. Next uh, stk stk function, this is 010 010. Okay, next printf, percent d and stkf 10 plus stkf 10. Okay, so what will be the output? Is it visible to you?
Yes, sir.
Yes, sir.
Yes, sir. Yes,
So
sir.
can you find out the output? It is the application of stack. So this is one get question, my function, and this is another get question, 2015. Get 2015. What will be the output? ষোড়াশিস
Yes, sir.
আউটপুট কি হবে?
Yes, sir. করছি।
শুভ্রকান্তি 9116 তথাগত
Yes, sir.
আউটপুট কি হবে মনে হচ্ছে? Should I explain?
Sir, 1 minute, sir. Just.
Uhini 9078. Uhini, can you guess the answer, Uhini? This is the application of stack. Sneha, what will be the output? 9052 Sneha.
Sir, like,
Yes.
okay, in the last line when we are at,
Yes, at the last line.
yes, in the last line when we are adding stack f1 of 10 plus stack f10.
Hmm.
So in the last case, the nothing will be returned. I think in the last call of stack f10,
Hmm.
nothing will be returned.
Nothing will be returned.
Sir, 15 can be the output.
Suraj,
Yes, sir.
how 15?
Uh,
And
Sir, in the last call, first it will return A1, and after that it will return A0.
Yes.
When we add both 5 plus 10, I mean, yeah, 10 plus 5, 15, I thought.
sir, like how can it return zero? Like because oh no no yeah yeah I got it. No, yeah it will be 15.
Suraj, what is the value of A0
A0 is 5,
and A1?
10.
So first, so first of all, stack F minus 1 and 10. Minus 1 and 10. This will be called first. Okay. So minus 1 and 10. So minus 1 and 10. So what is minus 1? Minus 1 is your opcode. Okay. And 10 is your value. Right. So that's why STKF, this is minus 1 and this is 10. Now minus 1 means inside the switch case, minus 1 means, so STK, STKF, STKF, it's minus 1 and 10. When this is called, minus 1 to 10, when this is called, then case minus 1 is executed, right? Case minus 1 is executed because inside the switch we are passing the opcode. Here the opcode is minus 1. Is it clear? So here inside the case 1, size is equal to value v. So your size is 0 and your inserted value is 10. So what will be the value of size? So size, what will be the value of size? Is it visible?
Yes, it's visible.
Yes, sir.
So size is equal to 10. Just put the value in the side. Okay. And Suraj, what will be the value of stack top after the execution of this statement minus 1 and 0? We know that value of size is value of v, that is size is equal to 10. Now what will be the value of stack top after the execution? Suraj, stack top. Anyone? What will be the
Yes.
value of stack top?
So in the first case,
Yes, in the first case.
stacked up will be -1 only.
No, 0.
Why?
Weight size is equal to 10 and stack top will be 0 for execution of case 1. হবে না এটা? কি দেখাচ্ছে?
ও আমি এটা লিখিনি নিজের কোডে, সরি সরি।
Stack top is equal to 0. Okay. Next calling function is stack top, stack f 05. Stack f 05. So stack f, STKF, stack f 05. So 05 means which case?
Is 0.
Case 0. Okay. So case 0. Case 0 means if stack top is less than is equal to size. Obviously, what is the value of stack top? Stack top value is stack
0.
top value is 0. So 0 is less than what is the value of size? 10.
10.
So 0 is less than 10. So 0 is less than 10. Now V is inserted at the stack top plus plus. Stack top plus plus. Stack top plus plus means so stack
A1.
top plus plus means no, not A1. This is A0 because this is post increment. This is post increment. First, what is post increment? First insert the value, then increment. Is it clear?
Yes, sir. Yes.
So A0 value, what is the A0 value? A0, your stack top after the execution, after the execution of the stack f minus 110, your size value is 10. Sorry, your size value is 10 and your stack top is 0. So 0 is less than 10. That's why your new function is 05. So 5 is inserted at the stack top, but it is inserted at the 0th location, then stack top is increased. So now after the execution of this line, your stack top is now at 1. Is it clear? Is it clear to you?
Yes, sir.
So
Yes, sir.
here A0 is equal to 5 and your stack top and your stack top is equal to increased value 1. Okay. Now next function. What is the next function? STKF 010. STKF 010. STKF 010. So which case will be executed? This is the last problem, okay? Which case
A0.
will be executed? Case 0. Now, what is the value of case 0 is executed? So case 0 is executed. Case 0 means if stack top, what is the value of stack top? Anyone? Stack top previous value? 1.
Stack.
1.
So 1 is value of size. Value of size is 10. So 1 is less than 10. So insert the V at the stack top plus, insert the V at the stack top plus plus. So stack top here 1. Stack top is 1 and the value is V is 10. Now after that, your stack top, what is the value of stack top?
2.
2.
2.
Okay. Now call. After that, we have to call which function? STKF. So these three functions are called. Now STKF10. Now STKF10 means which case is called?
Default case.
Default.
Default. Default. So inside the default function, a default case, if stack top. So if stack top means stack top value is now stack top value is now stack top value is
2.
2.
2.
So if 2 means if will contain a non-zero value for true. If 2, so 2 is non-zero value. So if block is true. So this will be executed, the return value will be executed. So what will be returned? Now this is the twist. What will be returned?
A0.
A1.
A1.
Your stack top is 2. Your stack top is 2. So 2 is true. So you have to execute this statement. Now this is the pre-increment. Sorry, pre-decrement. Pre-decrement. So first decrement, then return. So first decrement, 2 is decremented first. So this will be 1. So A1 is returned. So Suraj, A1 is returned.
Yes.
So
Yes, sir.
return value is
10.
10.
10.
Next calling function is again STKF. STKF10. This STKF10, this will lead to again default. Okay. Again, this will lead to a default case. So default case. So now what will be the value of stack top?
1.
1.
1.
So return minus minus 1, that is return 0. Return
0.
A0. Okay. So return A0. What is the value of A0?
5.
5 is the value. 5 is the value. So we have to return the 5. And we have to add this 10 and 5. So output is 15. Is it clear?
Yes, sir.
Yes, sir.
So 15 is the output. Okay. If you have any query, please ask me.